Engineering 305. I'm doing problem 8, or chapter 8, problem 175. Again, this time doing it with cartoons. Um, Same problem. Beam is loaded and supported as shown in the figure. Find the reaction at the supports A, B, and D. Now, if this were a standard engineering 305, or sorry, 202 problem, you can see I've got a reaction force. I really need to draw the free body diagram, which is going to look, well, I got to get rid of this. My free body diagram is going to look like this. I've got a reaction at A, and I've got a reaction at B, and I've got a reaction at D with a load there. Now I've got three unknowns. 1, 2, 3. And so that creates the problem. I only have two equilibrium equations. I don't have some of the forces in the x direction. So I get two equations. I get going with black. Sum of the forces in the y direction equals RA plus RB plus RD minus P is equal to 0. And based on my experience from last time, I'm going with some of the moments about D. And the reason for that is it's going to give me an equation that just has RB, RA, RB, and P in it. So I'm already eliminating one because I will get late. You know what? Maybe I should write that moment equation later, depending on what I get out of my cartoon. We'll figure that out. Anyway, I'll write it as the sum of the moments about D, which is the reaction force at A times 3L. But now, what's the sign? That's going to be negative. And the reaction force at B times 2L, and then minus. Sorry, it's not. That's a minus, and it's plus P times L is equal to 0. That's that equation. Now, I think this will be okay using cartoons. I'm not sure. But if I look at this loading scenario, what I'm looking at is a simply supported beam that's got a load, and I'm trying to find the deflection either at this point or at this point. And so that's going to be an equation that we've got, and I think I can just put those two things together, and the deflection at L, or that's B, the deflection at B, is equal to 0, and I can just put those two things together. It's going to be, I'm going to cross this out, and I'm going to have the loading scenario of that plus that. That's P, that's the reaction at B, and I should be able to just maybe solve directly for the reaction at B. I don't know. Let's start plugging it in. Now, first thing I'm going to have problems with, my equations are the cantilever beam equations. So I got to get the right equations. Hold on a sec while I get those up. All right, so I've got the right equations. So what I need to do is I've got two loading situations, and I got to put those in there, and they are. Loading case 5, where my load, if you look at loading case 6, that's where the load is in the center. That's not what I want. I want loading case 6, where I've got an A side and a B side. And B is always smaller than A. So actually, this is going to be okay because this equation is just going to, they're only giving us the one equation. And so then I'm just going to have to flip it when I do the other side. So we're going to have to think a little creatively about how we do this. So let's start laying this out. That I'm going to draw this behind the scenes so you can see this, so we can get this. I've got this situation where this is B and this is A. All right. And I'm going to put, they're putting a load P on it, and then I've got a deflection is equal to, and I'm going to go, deflection is equal to minus PBX over 6EIL. Oh, and that deflection is only getting, and then, well, let me write the rest of this. L squared minus B squared minus X squared. And that's only good for, oh, that's not what I wanted. It's only good for X's between 0 and A. So we have to be careful about how we apply this. It's only good for X's between 0 and A. So this equation works here, and that's okay because it works on the end point. It works at X equal to A. So that's okay. So we got to be careful about how. So we're going to think about the deflection from P. That's pretty straightforward, and I mean it for our P, for our loading situation. This P. Then when I do that, then A is equal to 2L, and B is equal to L, and P is equal to P, and what else do I need to know? I need to know L, B, X, E, I, P. I'm all good. So now I can substitute in, and that deflection is going to be equal to minus P, B is equal to L, X is equal to 2L, X equals 2L, 2L, and then I've got a 6EIL times L squared minus L is not L. L is equal to 3L. So I got to be careful. That means this term and this term, right, are not right. That's got to get substituted out. So that is a 3L, and then this is a 3L squared. That was close. That almost cost me. Minus B, which is L, so that's an L squared, and minus X squared, which is a 2L squared. Close that parenthesis. That's the deflection by P. And now I just got to go through and simplify that. Well, let's attack it. Let's just attack that right away. I didn't even hit it. That is a 9 minus 1 minus 4 times L squared times, this is a minus P 2 over 6. That puts a 3 on the bottom, so that all puts a 9 down here, a 9EI, and I have an L squared on the top and an L on the bottom. Cut that out. Good grief, I'm struggling. L squared on the top, L on the bottom, and I've got an L. And that makes sense because I should wind up with an L cubed. So that's equal to a minus PL cubed over 9EI. Oh, and I should have done this math. 9 minus 1 minus 4 is 4. So that's equal to minus 4 ninths PL cubed over EI. All right, so that's the deflection from, equals the deflection from P. Now let's do the deflection from the reaction at B. And this is going to be hard. Let's lay out all these rules, because now I have to look at my beam backwards. And what I mean by that is now my beam is, that's the reaction at B. Because this A has to be greater than B. Right? Let's go back to their thing. B has to be smaller than A. They say it the other way around. B has to be smaller than A. So I've got to do it that way. And so now, so we got to think through that. All right. So get that off the screen. So now my length is equal to 3L. I'm still gonna run with. Did I write the? I got to go back up here to that equation. It's the equation's right there. But the length is equal to 3L. A is still 2L. A is still 2L. And B is still L. And P is equal to RB. Oh, something about this. I got to think about this a little bit. And X is equal to 2L? I got to think about this. I'm going to pause it while I concentrate. Okay, what's got me bothered is X is equal to 2L, which is actually right for this situation. I'm looking at it. I'm looking at I'm looking at the load where I'm applying. I'm looking at the deflection where I'm applying the load in this case. But here's the problem. I'm not looking at the load here. When I look at this situation, I'm actually worried about the deflection here. X is equal to L. And so I screwed that one up. And that shows up here. So that's going to be, I'm going to drop a 2 underneath there. And it shows up at the end here. So that instead of being a 4, that's actually going to be equal to a 1. And so now this is not equal to 4. This is equal to 7. And this is equal to 18. So I caught that mistake. Before I got too far away, but boy, that was confusing. So now, but actually now, I should have that all done if I had not erased it. What that was? It was 4/9, wasn't it? So this ought to be the deflection from B is equal to 4/9. Now it's also going to be positive because I'm pushing up. Not P, but reaction at A, L cubed over EI. Now, what you got to realize is that 0 equals the deflection from P plus the deflection from B equals minus 7/18 P plus 4/9 RA L cubed over EI. Four ninths RA is equal to 7/18 P. Oh, let's multiply both sides by, multiply both sides by 9/4. RA is equal to 9/4, 7/18. P is equal to 7/8 P. RA is equal to 7/8 P. Now, for those of you who are watching at home, if you have already done the solution by integration, that's correct. Bam! So, at that point, in the integration solution, that's when I said I need to do the sum of the moments about D, because then I get a minus the reaction force of A times 3L, because, well, let's pull up the picture, because I can, right? And that the reaction force of A times 3L, that's going to be a negative. And then it's going to be minus the reaction force at B times 2L plus, because P does actually go the right way, P times L is equal to 0. Get that off your screen. And now, you guys let me screw up again here. This is RB. We've been working at RB the whole time. Good grief. Who's... Man, where's the editor? Good thing I... yeah. Okay, so RB is 7/8 P, so this is equal to minus RA times 3L minus RB is equal to 7/8 P times 2L plus PL is equal to 0. This is a negative 14/8 P. Oh my goodness. I'm gonna drop the L's from everywhere, so I'm good with that. Plus a P. So those are gonna get combined. And then I'm gonna put the RA times 3L on the other side. That's going to be plus an 8/8, so it's a minus 6/8 P divided by 3. Well, equals 3 RA. RA is equal to minus 1/4 P. And if you tuned in for the other one, you know that's correct too. And then lastly, you've got RA plus RB plus RD minus P is equal to 0, and just start popping through that. RD is going to be equal to 3/8 P. Boo! Cool. Cool. Okay, again, if we go back, find the deflection under the concentrated load. Well, I don't have the equation this time. I've got a method, that is, I can start going through this, but now I need to... Sorry. I've got this equation, or this method, but I don't have an equation. So, it is going to be a little bit more work. I'm going to wind up going through this process and redefining all my variables. This would actually, that would go to 2L, and then when I do it the second time, this one would go to L, and I can put it together. But good grief. I got this RA-RB thing all the way back here. Look at that. See? This is where you guys should have caught me right there. There's no RB in that equation, or RA. I think this was easier. And while this video is 20 minutes, the other one's 25. Yeah, I don't know. I don't know. Think about it. I made several mistakes that I had to go back, find, and fix. So I think this wins. But you get to decide on your own. I hope you're doing well. Don't worry, there's more coming. See you later.